Welcome to the Complete Engineering Podcast, brought to you by the University of Nebraska-Lincoln College of Engineering.
All right, welcome to the Complete Engineering Podcast. I'm Karl Vogel, coming to you from Othmer Hall at the College of Engineering, where we do big things as a rule. We have faculty and students who are doing projects that have an impact around the world and in the state of Nebraska. But today we're going to talk to some students who are hoping to have a big impact in other worlds, outer space. We have Matthew Biggie, Isaac Regier, and Simon Thingvall. Guys, thank you for joining us. And you are all part of the R.E.D Teams, which is a student organization. Tell us what is the R.E.D Teams and what do you do?
Yeah, so the R.E.D Teams stands for Research, Engineering, and Design Teams. It's a RSO, so a recognized student organization, basically an extracurricular here at UNL. The focus of R.E.D Teams is to help build hands-on education through kind of those research and design activities. So really what we do is a lot of NASA student research challenges, as well as some other design and engineering challenges as needed.
And where does your student population, the makeup of your team, where do you get your students?
So we're primarily from the College of Engineering. We have a lot of mechanical engineers, and then we've recently been branching out computer science, software engineering, some computer engineering, electrical, and then some of the maker group also has a decent amount of students from like engineering from engineering as well as architecture and the emerging media arts programs. Those students seem to really enjoy that. But we accept all majors. If you're interested in the kind of work that we do, we try to find stuff that is exciting for the team members.
All right. And now you mentioned these NASA challenges, and that's the primary focus of what the R.E.D teams are doing. And you had a long tradition of participating, or at least your organization has had a long tradition of participating and working with NASA. What are the challenges that your teams are focusing on, and what's the goal for NASA?
Yeah, so I can answer that a little bit. This year, we're taking on a couple of the different challenges. NASA puts out these kind of objectives to undergraduate students each year, and they're based on real mission needs. So NASA's looking to go back to the moon in the coming years, and as a part of that, they've put out a couple different challenges. And we have two of the Micro-G Next teams that have taken on some of those challenges. One of them is a zip tie installer for the International Space Station. And then the other one is a handle attachment mechanism that is used kind of on lunar exploration, spacewalks, and things like that. So those are kind of the two Micro-G side of things. Then we also have a suits team that's another NASA challenge focusing on like augmented reality with the spacesuits and things like that. So I'm sure we'll talk a little bit more about them later. But
right. Now, Isaac and Simon, you guys are part of the teams that are working on the Micro-G challenge, correct?
Yes, sir.
What is specifically the Micro-G challenge, and what are your specific projects? I know Simon mentioned them there, but what is it more specifically that those challenges are for you?
Yeah, so the Micro-G challenge in general is kind of specifically focused on NASA's EVA tools. So that's extravehicular activities, which is a fancy way of saying the spacesuit. Like when someone pictures an astronaut, the classic thing that they imagine is the EVA suit. And so it's tools to help out astronauts when they're not inside the space station or inside a rocket, when they're outside and need to work in a pressurized or fully depressurized environment. So the Micro-G challenge, we're developing these new tools. They put out different topics every year, different challenges on, hey, we in the upcoming missions a little farther out in the next several years, we're going to need a new sample bag dispenser because we're going back to the moon, or we need a new tool attachment device so we can have a bunch of different tools while only having to use one handle. So that's Micro-G in general, is basically extended brainstorming. They solicit all these challenges from different universities. And then more specifically, our team. So this year, they put out 3 or 4 challenges, and then we we submitted proposals for two of them. So one of them is a zip tie installing device. So that's in the spacesuit, they have those really big gloves. They're pressurized internally, so it's really hard to work with. And they need help basically being able to do anything because their motor skills are really impaired. It's like if you like any movement in those gloves, because it's pressurized inside, is like when you're taking a pool noodle and bending it, you have to compress the air to move. So it makes it really difficult. So we're trying to make tools to make it easier so you don't have to thread a zip tie on. You can attach stuff more easily to the outside of the ISS or future space stations.
And the zip tie is that now one of your projects is a senior design capstone project, correct?
Yeah, so that's a different project.
That's
so,
the handle project.
Yeah, that's the, I think the acronym is DRAT. I don't remember specifically what it stands for. But that is a tool attachment device. So that's the kind of the name of the game with a lot of these like design challenges for EVA or just aerospace in general, is making things lighter weight, figuring out how to get the most bang for your buck, because sending things up into space is really, really expensive and fuel intensive. So what they are trying to do is develop basically an attachment device. So imagine a shovel or a broom or something like that. Develop a really robust connector there that you can connect. You can bring up one handle that works with a bunch of different devices, and it's able to take a lot of load. So if you have to dig, if you have to mine, or any other things like that, all you have to bring is a bunch of different tool heads and then one handle, and then you're saving a lot of weight. And even volume is a major consideration on top of weight.
Right. And now, Simon, I mentioned earlier that these micro G challenges are nothing new for Nebraska engineering teams. What is the goal of these designs that you're doing, and where do you want to end up with them? I'm assuming Johnson Space Center, right?
Yeah, so ultimately, we go through the development of our designs. We have a couple different technical documents that we prepare. We have like an initial proposal where we're kind of explaining how our design will work and solve the challenge that they've put out to us. And then we get reviewed on that. And if we get approved, we get selected to continue with the project. We go into the prototyping stage, which is where we're at currently for this year. And we kind of build out our different prototypes. And when we come to our final device that we're ready to ultimately have tested, we'll ship that down to the Johnson Space Center in Houston, and then we get to travel. I think it's a few weeks later, there's a little delay, but we get to travel and follow it and actually get to see our tool put to the test by real NASA engineers and the dive team there they have at the Neutral Buoyancy Laboratory. We got to do that this past summer for the first time, which, well, in a couple of years, I guess, because due to the pandemic and everything. But it was a really cool experience, really awesome to kind of get to see everything firsthand and know that you're really making an impact on the space program, because it's, you know, something where you've spent all these months working on a device, and then they take it and they're actually testing it in the real facility where they test the ones they're going to take to space.
Yeah, we saw pictures earlier from the Neutral Buoyancy Lab there. How does that how's that involved with the testing process of your devices?
So basically the NBL is a giant swimming pool, and they can use it to simulate microgravity environments. So similar to the moon, Mars, or even the International Space Station, they'll weigh down an astronaut diver to simulate that gravity environment and then test the device as if they were on a different planet or out doing a spacewalk around the space station. And so the student teams, us included, get to go. We get to sit in the control room, write up procedures for the divers to use our tool, and then ultimately collect the data and write a report on how the testing went there in their facility.
Isaac, now these have extra world applications for NASA, but are there other ways that maybe these devices might inform some of the things that could help us here on Earth?
Totally. Yeah. A lot of when I'm bringing new people onto the team and trying to explain some of the constraints that we're designing around, I end up realizing that it's very similar to like designing for people with disabilities or even differently able people in whatever capacity. So for example, I mentioned how it's really the motor functions are impaired. Even like visibility is really impaired. Learning those design skills, you end up kind of becoming more empathetic in your engineering practice. So it's a lot more with arthritis, or someone who's a little more elderly, has lost motor function, maybe even some people with Parkinson's. So like the zip tie installer device is meant to be as simple as possible, that you push it around and then pull one thing, and then that is your whole actuation. Zip ties installed, you're good to go. So that could really translate to even just from a design skill of people. Our engineers that graduate know how to design for people with disabilities, and potentially even the device could be adapted. So NASA does this thing called the technology transfer program. So like the astronaut ice cream, all those things that you hear that say, hey, this was designed by NASA, and now we use it. I think even Capri Sun is a product of the technology transfer program. Yeah, the pouches. So those thing that is like, we're developing these specifically for the EVA tools team on the ISS, but since it's a government agency, they're really happy to get use out of them in whatever capacity. So there's kind of two sides of that like we're learning how to design for people, for different people better, and then we're also designing a device that could potentially be adapted.
Now, Matthew, you're part of the suits team, and that's a new kind of a new challenge for the Nebraska students this year. How did your team come together, and give us a more detailed explanation of what NASA's seeking in the suits challenge?
So first off, SUIT stands for Spacesuit User Interface Technology for Students. So the most basic way I like to explain it to people is that we're making kind of like the HUDs that you'd know from like sci-fi movies and games. I always say Halo, or like Iron Man or anything like that, that it comes up and it would give them all their information a lot easier. Really what they're looking for us is to develop a system to help the astronauts in that limited mobility and accessibility, as we mentioned earlier, to allow them to check their bioinformatics and do their mission objectives a lot easier. That primary focus being the bioinformatics, actually. Currently, they have a large chest computer, or a large chest board that can let them see everything for all their suit information. So,
and that's on the outside of the suit?
Yes, it's on the front. If you see the suits, there's that big bulky like box on the front of it. That's where all that information is. And so they actually currently use a mirror on one of their arms, and they see right here, and they have to do it really awkwardly in the suit to try to turn the knobs and change things and see all the statistics about themselves. So if we develop a system that puts it right up in their face, and they can see it and modify it right there with tools such as the HoloLens that I'm wearing right there, then it would be a lot easier for them to be able to access all the information and possibly change parts of it.
So that's kind of communicating with a server or a computer somewhere else that can help you do things sort of similar to what we might have seen in the movies when Tony Stark was talking to Jarvis in the Iron Man suit. Is that?
Yeah. So beyond like connecting to the other equipment in the suit, the system's supposed to be multifunctional with working with other equipment and other systems. So navigation is a very big part of the system, in that we need to help them navigate from point to point and make sure that we can tell back to NASA exactly where they are, coordinates wise and direction wise. And then there's other equipment that we're planning to work with, being a rover that we're going to use that navigation software to help tell where to go, along with identification equipment and the egress procedure. So actually, that's a very large portion of it, using the UIA system. It's the umbilical interface assembly, where essentially, if you see some of the photos inside the space stations where they have to like crawl into the spacesuit and they lock it behind them, they do all the sealing. That's the like airlock system, essentially. It's where they do all the pressurization and they get the spacesuit ready to go on the spacewalk. So helping with the steps for that and making sure they do everything right is actually a very large focus.
And so specifically, what is it that your team is developing?
So we're developing a AR project for the HoloLens. Again, the equipment that you saw me wearing there a little bit ago. We're using that equipment because it's probably the most related to what they would want to actually install into the spacesuits. And it's being developed via Unity as a pretty simple Unity project. But it's been really fun trying to get working with the mixed reality toolkit that Microsoft provides for it.
Yeah, and this is different than the Micro G challenges where NASA issues a list of things they're looking for. You kind of have a little bit more latitude. Is that a little bit?
A little bit. So Micro G focuses on 4 challenges that they put out that it's mission specific. So it's like, oh, we need the zip tie installer, or we need this handle assembly that can attach different tool heads. Suits, there's not really, oh, like this person's doing this and this person's doing this. It's that they gave us a list of requirements that every system is supposed to have, and we're just supposed to accomplish those. So you could think of it kind of like Micro G's in a way, that we just have 1 challenge while they have 4 to pick from.
Does that make it easier? I noticed you were part of the Micro G last year.
I'm still part of it this year,
Yeah,
actually.
but you were part of those Micro G teams last year.
Yeah.
What lessons did you learn from being in Micro G that have helped you in developing the suits team?
So just kind of, I would say team organization and just the development cycle. Of course, attaching things from my coursework, but doing another NASA project in the past and knowing like how to progress through deadlines and progress through all the different paperwork and different aspects of the development process for the research was really helpful in setting this team up.
Now, Isaac and Simon, last year, the Micro G teams, one of them had a device that NASA chose for further study, correct?
Yeah, so I was a part of the team last year where they decided to keep our device and do kind of an integrated test with it. And so what that was we were one of the top, I think 3 designs that they had down there. And they took our device and tested it along with the top suits software as well. So there, you can kind of see the crossover between the different challenges in that way. And so there's the top suits student team, and then our device and a couple of the other top devices from the other challenges. We're all kind of tested in this integrated full systems test. They're trying to just kind of see the capabilities of everything. So that was definitely really cool to know that they liked our design enough that they wanted to continue working with it and continue to get some more data out of it. Definitely makes you feel like you're making a big impact and like you're really contributing to the space industry. So really awesome.
And what things did you guys learn last year from those Micro G challenges that are helping your team, giving you an advantage this year? Because I've read not everybody gets selected for this program, that there are essentially maybe 40 slots among those 3, the 2 different challenges maybe to get there. And here in Nebraska's got 3 teams going.
Yeah, so there's there's a bunch of Artemis student challenges, and then we developed these proposals kind of early on in the year, and it's really quick turnaround from when the school year starts to they announce them. Then we have to recruit new team members because they really there's a lot of turnover as a student kind of extracurricular research team. But then we developed that proposal by Halloween. Essentially, we've got a full design concept and animations of video that we send over to them as our research proposal. They never announce a specific number, but for each challenge, they only accept a certain amount of teams, and sometimes they accept even less if there's not good proposals. So for Micro G, they select about 30-ish teams in total, and then Suits is different since they only have the 1 challenge. Yeah, Matt.
Suits is about 10 to 15. I think, actually, no, it's 15 universities. I believe it's 10 teams this year.
Yeah, but in the past, we've applied for multiple challenges. We've always, so the Micro G program on the NASA side has existed for, I think, 8 or 9 years. And every single year it's existed, we've been able to sound down at least 1 team. But we generally develop a couple of proposals just because we want to kind of branch out and have the best chance of being accepted, as well as just having more people, the ability to get more people. But the past 2 years, we've actually had 2 teams accepted on Micro G, which has been kind of the most successful yet. And then first year on Suits, so we're sending 3 teams down to NASA total. It's I'm very happy with the way the club has been progressing.
Yeah, and obviously you guys are continuing to build on a foundation with this team. What what sorts of things are you gaining from being a part of these teams that are helping you in your academic career, and what sorts of things are you learning that other students might benefit from learning?
So I guess personally, coming into college, I was interested in space. And so when I went to the Engineering Rock the Block Fair, I was kind of looking for RSOs where I could get involved with something relating to NASA or something relating to space. There's a couple different clubs on campus, but this one really stuck out to me just due to the chance that we might actually get to go down to Johnson Space Center to test something that we've been working on. That was something that was really attractive to me. But through the club, I learned a whole lot of CAD skills. So we use SolidWorks pretty much exclusively for our projects. And there's a SolidWorks class as part of like coursework for my major, but I didn't take that until probably second semester of my sophomore year. And so I learned like way more about SolidWorks and CAD in general through the club than I even learned in the class, which I thought was really a neat aspect that this RSO is like brought to my educational experience. Like and I mean, CAD's not the only thing either. You learn manufacturing, you learn how to build these things, how to test these things, and it's just really a really good way to get kind of a well-rounded project experience like early on in your major, which I thought was really cool.
Now it's building this skill set that engineers need to have, and learning how to do things as an engineer, and one of those things is iteration after iteration of different things and testing. How foundational has it been for your academic success? Say, Isaac, I remember talking to you that you said this was a pretty big deal, and that you think this is something students should be able to build on.
100%. I feel like for kind of my success and trajectory as an engineer or designer, like the club R.E.D Teams, like I got involved with it very, very early on. This is the first club that I joined. And then I started kind of taking over. So I joined Micro-G when it was just Micro-G, and then we kind of formed it into R.E.D Teams and founded it as an official RSO. But I think I would be in a totally different place if I didn't do these extracurriculars. I'd be nowhere near the level of competent that I am at all these different areas. And even just like learning, like I end up doing 3D printing research, and I'm applying full-time jobs now and looking at a lot of 3D printing companies, aerospace companies, all of this. And I got into that because we had a need within the team that was, hey, we want to prototype a lot quicker than sending parts to the machine shop. And 3D printing technology is always getting better. So then I ended up looking into engineering materials, 3D printer plastics that you can use for functional materials instead of just fit checks and all that. And then I've built that out for the team. And so that has really helped me and changed the trajectory, and like learning those basic skills is something if I didn't have to do that because I had a project that needed it, I would be in a totally different place. Like there's one thing that how to get an A on elastic bodies tests and you solve for the deflection. There's a whole different thing that when to use it, how to use it, if it's useful at all. Particularly like our club, but even just any extracurricular that's kind of project based like this, the College of Engineering special project funding that comes from the Engineering Student Advisory Board, I think makes our college particularly exceptional as compared to other undergraduate engineering programs.
Now, Matthew, I'll close by asking you this. Maybe it's the best way to close this out. The experience that you're getting here in these teams, and maybe it's open to all three of you, has it changed your decisions when you came to the College of Engineering? Has it changed your pathway to a professional or post college career?
To an extent, I agree with Isaac that the skills I learned here most definitely have. Like him, I'm also graduating in May, so I'm on the job hunt. I'm looking at everywhere, but definitely checking out aerospace as a major consideration, and looking at NASA jobs in particular, actually. So how it's changed it a lot, it's more so in that it's taught me a lot of skills in how to actually develop these products. In terms of inspiration of where to go, it's pointed me in that direction. But I'm pretty open to anywhere now, and I know I can succeed. So,
Yeah, I would echo that. I've definitely learned a lot of things through the club. I'm a third year, so I have another year before I graduate. But I think like through the skills that I've learned in the club and everything, like I'll be able to transfer a lot of those to whatever career I choose. I'm definitely leaning toward like something in the aerospace realm. I've got a internship at an aerospace company this coming summer that I've been honored to be selected for. But I think kind of like Isaac was alluding to earlier, and these skills that we're learning can apply to a lot of different areas, whether that be medical devices for people with arthritis or whether that be, tools for astronauts. It can apply to all these different areas. So I don't like to say that I'm going to choose one job and only one job. I like to keep my options open, but I think the club has kind of just really rounded out my resume and my experiences, my skills to be able to go wherever I need to go. So
Awesome. So when would be the trip to Johnson?
So we're heading down both. So we're a couple weeks apart, but it's going to be right as soon as the school year ends. The NASA suits teams head down, and then immediately first week of June, the Micro G heads down. So we're back to back. End of the school year, we got to get our devices ready.
Graduation to Johnson to whatever else is going on.
Exactly, to the rest of our lives.
Funny enough,
yeah. Go ahead, Matt.
the suits team is leaving on graduation weekend, so I get to fly out.
Wow. It sounds just like the engineering students here. They're always busy, and you're going to keep going through the summer on this. Congratulations on getting your teams accepted. Best of luck going down to Johnson, and thank you for joining us today.
Thank you.
yeah, thank you very much.
Have a nice
Appreciate it.
day.
Thank you.
Thank you for listening to the Complete Engineering Podcast. For more information, visit us at engineering.unl.edu.